Okay, we're going to talk about potentiometers, and that's what this guy's got in his hand. And a potentiometer is nothing more than a variable resistor. Now, they make different types of potentiometers, and we use different types of potentiometers for different reasons. And I'm going to show you what he's doing, and I'm going to speed up this video just a hair. He doesn't talk in it. He just um, has some weird audio um, playing in the background. But notice there's three legs on this pot, and you might be able to see it. It does say it is a 10K. It was a 103, which is 10 with three zeros behind it for a 10K. He's just showing you the dimensions, and you notice this 10 turn one is a lot thicker than this one turn, or it's actually less than one turn. We can't even make a full rotation of the knob on this guy. One of the things he's doing is measuring outside leg to outside leg. And that's always going to measure the value of the pot. In this case, 10K. He's on the 20K range, measuring 10K. He's going to do the same thing on this one. Now, this one's a little different. He's going to measure outside to middle, but that is the full value of the pot. So turning the knobs on either of those would not adjust the value. He's going to show you how you can adjust the value. We're going to have to go from an outside to a center there. And I'm going to show you this pot in a little drawing in a minute. And he's just turning it, and he's going from 0, and he's working his way back up to 10K. Now notice, how, even though he's turning it very slowly, how quickly it reacts. So you don't get a lot of precision out of these, but you do get a quick turn uh, change in the value. So he's just went from 0 to 10K relatively fast, and he was moving it pretty slowly. Now on this one, he's going to have to turn it quickly to get it to move, pretty quick. And you see how hard he's dialing down on it to get it. That's because that one takes 10 turns from start to finish to get the full value of the pot. Now this guy's laid out a little differently. He's more of not cone shape, but cylindrical shape, whereas this other one's flat. And I'm going to talk about this other one that's in the background. I'm going to let it get back up here in a moment so you can see it. But you can see he can set this thing dead on 1K. It doesn't take a whole lot of effort. You could set this other guy dead on 1K, but it's going to take bunches of effort to do that. I mean, lots of time and lots of hair pulling to get it dead on any value that you're trying to shoot for, other than one you just randomly turn to. But this guy, we can set him pretty quickly to whatever value. I'm going to speed the video up a little bit. So a lot better resolution. I may have to go back. Here's our other pot. I'm going to draw this guy a little bit. It's going to be a crude drawing. I am not a drawer, but I want to start out with just a board. Let's say that is a length of board, and this board is 10 feet long. So obviously, if I come in here and cut this board dead in half with a saw, I'm going to have 5 feet one way and 5 feet the other, but the total length of that original board would still be 10 feet. Or if I came along and cut that board where I had 2 feet this way, I would have 8 feet that way. But outside to outside, it's still a 10-foot board. It's just going to depend on where I put my saw as to what the two pieces come out to be. That might be 3 and 7. That's all a 10K pot, or any pot. I say 10K, that's the value we're using here, but that's all a pot is. We use a different color other than gray. Let's use, I don't know, blue. So we've got this round form factor, and of course it's got some depth to it, but we're just going to pretend for now that it's just 2D. So we've got, um, that's not dead center. I'll try one more time, but if not, we'll just have to pretend that that's dead center. We'll call that dead center. So this is our knob, and this is the outside body. And remember, we got 3 legs that come out of here. Can't draw a leg with a circle, so let's try a line, shall we? We've got this leg, and we've got that leg. Now, what's inside of this pot is this material. Well, I didn't mean to turn that green off. Start over. So let's redo that, but let's make it gray. Okay. So from the two gray legs, and I know they're kind of different colors, so my apologies for that, but from the two gray legs, we're going to measure 10K. Now, if I come up here and I'm going to show you that material that's kind of in between them, and I'm going to represent that by green. But what happens is there's this very thin wire. It's not near this thick, but it's laid out over and over and over and over and very uniformly, not nearly as um, messy as I'm making it look. But that value, it's a resistive type wire. That value of that full wire from here to here would be 10K, just like the value of this board from there to there was 10 foot. So I can't change the fact that outside to outside, this board's 10 feet long. Neither can I change the fact that from this point to that point, which is the same as where these legs are, is going to be 10K. That will always be true. It's just where I divide it that changes it. And the way we divide it is we have this thing called a wiper that extends from the center. And I'm going to use a line there, not the free tool. And so here's this wiper that can go around and divide this resistive material. Now, before I leave that wiper there, I'm going to come in and add a third leg, this middle leg here. So um, when I put this wiper on, this third leg is right here. So obviously right there, the middle leg is close to the outside leg. So I'm going to measure a low resistance. Uh, the middle leg closest to the left-hand leg, I should say. So I'm going to measure a low resistance. But to the middle leg, to the right side leg, I'm going to measure very high because I'm having to go through all of that green material from here to there. So I might be measuring 20 ohms here and close to 10K here, or I might be measuring 500 ohms here to here and 9.5K here, 9,500 ohms. So, but if I had that center leg pretty much in the middle, I would measure 5K between middle leg to here and 5K between middle leg and here. So it just all depends on where I divide this resistive material as to what I measure from the middle leg to each of the outside. So obviously, as right now we're measuring a low resistance from the middle to the left, we're measuring high to the middle to the right. But as we move and cross the center point, we swing the pendulum a little bit and we start going higher on the left leg to the middle and lower on the right leg to the middle. So you get the idea, just like if I'm dividing this board right here with a saw, um, you know, if I divide it dead in half, then we've got equal amounts on each side. If I divide it closer to one end, then we're going to have a longer value on the other end. Same thing here with this middle leg. It just depends on where I do. So now we talked about a linear pot. And if you noticed in the eBay purchase in that video, if not, you can go back and look. He bought a linear pot. And linear comes from the word line. And so just like we have an XY axis here, I'm going to draw you a quick XY. If I can get this tool to work, it's being persnickety. Here we go. So here's our XY axis. And we'll say that this is 0 ohms. Hard to draw an omega symbol with the mouse. And this is 10K. Well, what happens for every degree of turn, we're going to rise between the middle leg to an outside leg. If we start at 0, we're going to rise linearly to 10K. So halfway, we'd be right in the middle, and 1/10 of the way, we'd be right here, and 3/4 of the way, we'd be right here. And that value relative to 10K is going to be linear. Now they make a pot called an audio pot, and that audio pot does a little bit differently, and it has to do with the layout of the screen material that's inside. If you think about volume controls on the old radios where you used to have to dial them by hand, I know a lot have buttons, but you get kind of like this kind of output out of it. And what happens is you got a slow ramp until you get about midway, and then boy, when you turn it, it gets really loud. We've got a good degree of movement here. We can kind of set that volume where we want. So right at first, it's kind of rising slow, but then boom, right there toward the back end, it rises very rapidly. And that's the difference between an audio pot and an audio pot. The way it divides that resistance up is a little different, so we get a little different feature. We're still, whoops, that was supposed to be a straight line. We're still varying between 0 and, wow, a triangle. You know, we had that in here. Quick line. We're still varying between 0 and 10K, but how we get there changes between a linear pot and an audio pot. So they're all still variable resistors. It's just the features that make them a little bit different in the way they change that variant. So hope that makes sense to you, but if not, as always, feel free to ask us questions. We'll be happy to help.